Get Electronics. Today we're gonna study about history of LabVIEW first. The history of LabVIEW started in the year 1983, and next LabVIEW 1.0 was started in year 1986. A very crucial year where the developers have developed many things, but usually many of you know that the new software will have many bugs within the new starting stages. So the first LabVIEW software was developed in 2005, and that is LabVIEW 8.0 release with many bug fixes which made the software good to get its original structure, and the way it got executed was very fine. And next, presently LabVIEW 2019 is on the platform, which has many features and inbuilt libraries, and community libraries has been increased. And these community libraries you can download it from VIPM. VIPM is nothing but VI Project Manager, and in this VIPM we can download many community libraries. And coming to the next, pros and cons of the software. The pros and cons are nothing but advantages and disadvantages of the software. Coming to the advantages and coming to pros and interfacing to device. Many devices, vast devices we available in the market. We have like Arduinos, Raspberry Pis, and NI DACs, data acquisition systems, and many more things we can interface with this software. And we have a large number of libraries where we can have, like, we don't need to write every library always, and we can utilize the inbuilt libraries whatever the LabVIEW is giving us. And next, coming to the parallel programming. This parallel programming concept is nothing but, unlike any other software or any other programming language like C, Java, etc., where we write the program first, again we debug, and again we go for the output, all those steps will be out from this parallel programming in LabVIEW, where we will write the program and we will parallelly see the output. In future videos we will get through those parallel programming concepts. And next, ecosystem is nothing but connecting everyone in the world. Like, ecosystem is like a community where all the VIs or the done by me or you can be shared in that community, and that will be utilized by the person who need it. That is called the ecosystem. Very vast ecosystem which you have with LabVIEW. And next, coming to the cons or the disadvantages, it is slow in its performance, because LabVIEW being a very big software and it has graphical programming, where graphical programming will need much heavier graphics, as well as it LabVIEW always uses runtime software. With even a small LabVIEW program also, it needs the very big runtime program. It might be a big or it might be a small, it uses the same runtime program. Next, coming to the non-textual, here we can't write any textual program. I'm saying you, it's not textual program, but you can have some textual things like adding labels to it. Next, coming to non-zoom function. In the programming panel we can't zoom any VI graphical image, and we can't zoom it. That is the main disadvantage. I can say slow and non-zoom function is the main disadvantage, and non-textual is not the big disadvantage, I can say. Next, coming to the VI package manager. JKI is the company which has introduced VI package manager to the LabVIEW. And VI package manager, you don't need to install it separately, but it can be directly installed using LabVIEW. Next, coming to the VIPM. VIPM is an application developed by JKI, I already told you. And next, coming to it, consists of add-ons or libraries for the LabVIEW, and they can be installed directly to the LabVIEW libraries folder. When you open JKI VI package manager, you can search any library you want and you can go for the installing of it. Next, coming to the ease of interface. Different development boards such as Arduino, I already told you, Arduino, Raspberry Pi, etc. can be interfaced directly, but we can interface without these package managers or any add-ons or libraries. But we can use these libraries to get rid of writing big programs, because has already wrote these programs and they are giving us as an end product and we can use it. And v.vip is the extension of VIPM package. If in case if you want to do any contribution to the community, or you want to give any contribution to the community, you can make VIs, you can package them into .vip extension, and you can upload it into the JKI VI pack. Next, as like many other programming languages, we have preprocessor directives in LabVIEW, which will include loops, mathematical operations, and many more. And this is called preprocessor directives. These are already included in the installation folder of the LabVIEW, and these are also called as libraries. stdio.h and math.h. These libraries or header files will consist of printf, scanf, etc. few mathematical operations in header files. Here we have many preprocessor directives, and we don't need to include automatically. They'll be having, because it's a graphical programming. Coming to the next, writing your first program. We usually write a program in C, and this is my normal C program to add two numbers. Just I'm gonna write for you. This is the C program. Yes, it will add two numbers and you're gonna get some output. That output will be from C. This is a LabVIEW program. Just I'm showing you the block diagram here because I can't zoom. I already told you the disadvantage of the LabVIEW is I can't zoom. The output panel can be zoomed and you can be shown with that. Just we're gonna see into the LabVIEW now in real time. This comes our LabVIEW open. I already done a video on this, getting started with LabVIEW. You gonna check link of that video in the description. Here in just this diagram is nothing but a programming panel, and coming to the front panel, this is called output panel. In block diagram we'll write a program. Just we see in right click on the block diagram, you'll be getting functions. Here you'll be having many features. LabVIEW has a vast and big libraries built in. So in C we have in loops, for loop, while loop, time structures, case structures, events, etc. These we have arrays and strings and pointers, etc. Many things in things. The same way we have many mathematical operations. Here we can see add, subtract, multiply, divide, quotient, etc. Click on this add and I'll place here on this will be my graphical, and you can see I can't zoom it. I don't have any option for zooming it, and I'll press on, I can click on help here and I place my cursor on this VI. So this add VI, what to do now? Next, coming to this one, if you right click on the first terminal, you can see many options again. Create constant, create control, create indicator. Then here we have control. I take control, I just drag here, again take control, again just drag here, and for output I need an indicator, so I'm just taking an indicator here. Now you can see this is parallel programming where you will be seeing all the inputs and outputs here, and you're gonna drag and drop wherever you want and you can run this program. We have done the program and you can see here I don't have any errors. If I have any error, let's create an error here by selecting this. Just I am deleting the wire and you can see I have some error, and if I click on this it will list some errors, contains unwired or bad terminal. I'm gonna just again start wiring this one, and I can see here I'm getting run. In this front panel, if you go and give some inputs like 7 and I can give any value 7 and I'm gonna give 10. So if I press run, my answer is like 70. If I gonna change this one, don't get a real-time output here because I'm not continuously running this program, I'm just running this one. So when I run, always it will be compiled for once and it will be showing us output. And if press this one, we can change the values here and you can see the real-time output here. So I'm gonna change any value from X and Y. We can have multiple. This is what now if I want to stop it, I have to stop here, or if I want to pause this VI, I can pause here. I'm gonna stop this one, stop. Thanks for watching my video.